No, the only one on here that I am unsure about is 4, just like TJ.
Mm-hmm.
But I think I figured it out.
What's your last name?
Moss, M-O-S-S.
Okay. What did you do when you say participated but not shown?
That's what I did. Because he talked to the teacher, so he obviously, like, the teacher is aware of what's going on.
Mm-hmm.
But that just
he's been doing everything early, so.
I was going to say, I haven't had a problem with how he's doing things, so.
I don't either. Okay, I just posted our thing.
Awesome sauce. And if someone shows up, they can either comment underneath it or we can edit it later, but.
Yeah.
No.
Okay.
No. Do you want to start or do you want me to?
I can start.
Right.
Okay, so suppose we have a set of paired data, let D equals X after minus X before. The null hypothesis is that, I still don't know how to say that. An alternative hypothesis is, and the population standard deviation is not known. Jordan collects a sample size of n equals 9 and computes the difference to be 2.2 and the sample deviation.
All right. And I just want to make sure you are aware that's not difference. That is actually the sample mean.
The SD?
The D with the line over it is the sample mean.
Oh.
Just a D is the difference. Or actually, it's D. Oh, yeah, just the D is the difference.
Okay.
And then the D with the line over it. I don't know if that helps anything, but just so you.
No, it does. It helps a lot. That makes sense. I wasn't sure why it worked out, but it did. Okay. So what is the value of this test statistic? I got 2.
Yep.
So.
And it makes more sense now because the D is the sample mean.
Yeah.
Right?
Because I put D over it because that was the only other thing I had. So I tried it and it worked. But I was like, that doesn't make any sense. But now it makes more sense.
I'm glad we caught that.
Yes, I am glad that too.
All right, so for the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403, and using the probability to determine the p-value for Jordan's hypothesis test. And I got 0.020, which in my mind, I was going to say, because that's like, it's a 2-sample t-test, and they're giving us the probability, which is the same thing as the, or it's a 2-tailed, sorry, not 2. But it's 2-tailed, and they're giving us that probability, which is the p-value.
Mm-hmm.
But since it's looking for what's greater, it's just looking for half of the p-value, right?
I think, and I plugged it into that applet. That's what I did. I put it into the applet, and it showed up with that value whenever I unclicked the left-hand side.
Oh, see, when I did it on that, because I put in 2 as the test statistic at the bottom, and when I unclicked half, I got 0.0697. And that was wrong, because I did 0.07.
I put the test statistic, like, in the little graph, in the applet thingy, I put in, at the top, 0.0403. And then I unclick. Wait, what did I do? That is not what I did.
Okay, so you did, it's basically, so you have both of them clicked like it's the actual p-value. And then once you have it, you unclick 1. And it gives you that? Is that what you did?
Yeah, but now it's not doing the same thing. What did I do? Hold on a second. Before. Oh, that's not what I did. I did it mathematically. So I put the mean, I did that z minus bar thing,
Oh, yeah?
and I did the d over the standard deviation divided by the square root of the like number there are. And so I got, oh yeah, I had to do this roundabout. So I plugged in, hold on a second. I am doing something wrong. What did I do? That's what I got, but I don't remember how I did it. Yeah, I don't know. What the heck did I do? I hate it when that happens. This is why I need to write stuff down. Okay, enter. Do you remember, what did you do again?
So I did the logics of, because we're looking at the alternative hypothesis being not equal to, meaning it's a two-tailed test, and they gave us the probability or the p-value of the two-tailed test, but we're only looking at one tail of the test. So I just took the p-value they gave us and divided it by 2.
Oh, okay, that makes sense.
Which is what I thought. And I tried plugging it into the applet, and I got a number way bigger, and I turned it in, and that wasn't right. And we already know that 0.04 isn't right because that's what TJ did.
Yeah, that makes sense
So,
though.
I was gonna say that I don't know if it's right yet, but that was kind of like my last ditch attempt at logic.
Yeah, and it makes sense to me, so.
I'm glad.
Okay, use the data file to answer the next 6 questions. Perform a paired sample t-test. Be sure that group test, do group 1 minus group 2. The level of significance is 0.1. So for the test statistic, okay, don't make fun of me, but I keep having problems with what the heck a test statistic is. So isn't that what Z is?
That it's the equivalent, except in this one, you don't always necessarily need like a U. So it'd be like, it'd just be basically in this case be the sample mean over it, but to find it on SPSS, you do the you have to find the difference.
Yeah.
And then you have to do a one sample t-test, which flashes back to
Last chapter. Did you get 0.407?
Yes, I did.
Okay, good. That's what I did.
Awesome. And do you have any clarifying questions, or do you feel comfortable with what you did?
I understand what I did there because I just,
Okay.
it's how I maneuvered the software.
I just wanted to make sure, because I used to get like right answers on accident all the time, and then when I got the right answer, no one wanted to explain it to me. So
yeah. Okay.
And then the p-value, I got 0.689.
This is where I didn't get to. I'm so sorry.
You're fine.
Okay. So the p-value, did we get that by plugging in the test statistic to the applet?
No, it actually gives you, if you open up the one sample t-test you just did, if you look under sigma two-tailed, it says it right there. That's the p-score, or the p-value.
I'm sorry, what's a p-value? There's too many value thingies.
P-value is the probability.
Oh, okay.
So it goes with the applet, but because we already have the data file in the
we don't need the applet.
Yeah, it just gives you the answer. And the only thing you really need to remember is that it says sigma two-tailed.
And
so you just have to
you just have to divide it.
Yes, I was gonna say you just have to watch for what tails it is. Otherwise, I mean, like, that's gonna be, once you get in the habit of looking there, the only thing that's gonna screw you up.
Yeah. Okay, what is the correct decision based on this evidence? So the P is not low. So we failed to reject it.
Yep. And then your alternative hypothesis is greater than, so what is the correct decision? And then we have insufficient evidence that the mean of the difference is greater than 0.
Yeah, that makes sense.
Because in that case, we divide it by 2, and that'd be low.
Uh-huh.
Yeah. Awesome sauce.
Okay. Let me open up this other one. Okay. Sorry, I'm moving everything over to so I can do the little t-test thing.
You're fine. Like I said, I'm not in any hurry. I'm just going to be going back to bed, so.
I'm sorry I'm postponing your nap. Okay. Which is greater, n or isn't that the difference?
The DF is degrees of freedom.
Oh, okay.
And again, we learned about that last lesson.
Yeah. Okay. Are they both on the same thing?
Yeah. I think that one might be, let me double check, but I think that might be under explore, not t-test. Like you have to do the explore thing. Yeah, it's under wait. Sorry, I gotta find it and make sure I'm not giving you false information.
Okay.
No, yeah, that's still under sample t-test.
Yeah. They both popped up on the same page. So I'm trying to figure out, okay. Okay, so the degrees of freedom is 21. And did it say for the T?
No, it's N.
N, okay. Degrees of freedom is 21 and N is 22, so 22.
Yeah, so N's bigger.
15. Oh, that makes sense because N's of freedom is 1 minus N, or N minus 1.
Yep. Like realistically, you shouldn't have to look it up, but I totally blanked on that equation too. So I looked it up and it's like, you know what, this works.
And then I realized it after.
It's like, if you got to the right answer, that's the point.
Yeah.
But it's also nice knowing that you always have that information.
Yeah.
And then the p value is 0.001.
Yes. Okay. What decision do you make? 0.01, 0.001. So we reject, P is low, reject the null, so we reject it.
Yep. Yeah. And then if you decide to make the alternative hypothesis greater than 0, the level of significance or the p-value will decrease.
Correct.
Because you have to divide it by 2.
What decision do you make? Reject still?
Yep. And then we have sufficient evidence that there is a mean difference between the two groups.
We have sufficient evidence?
Yeah, so it's the third one.
Okay, sorry, I'm trying to wrap my brain around it. So,
okay, so if you have to go back to kind of like the original hypothesis, where there is, so like the alternative hypothesis is there is a mean difference because it's not equal to 0, right?
Yeah.
And because you reject the null, that means you go with the alternative hypothesis. So we're just the alternative hypothesis here.
Okay. Sorry, I've been writing essays for like the past 3 days, so my brain's a little fried.
Math is horrible no matter what you go through. I'm not going to blame you for asking questions or being uncertain, especially at 10 o'clock on a Monday.
Exactly. Oh, I'm about to die.
That would kind of suck. We only have 4 more questions.
I know. Especially since I'm the one broadcasting. That'd be awful. Okay. We're on 15. Okay. As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? Greater than, less than. The second one?
Realistically, it'd be not enough information because you can guarantee that the greater than or less than will give you less than like the equal to because you have to divide it by 2.
Uh-huh.
But realistically, you can't be more specific than that because certain problems less than, I mean, like, there are certain problems where it'll turn out differently, or, I mean, it's not something you can identify just by that information.
Okay.
And then 16 is 11.955, the point estimate.
Yep. Margin of error. Hold up. Dang, what was that one? What was that formula?
Well, realistically, you should be able to find it in Excel. I mean, in SPSS, but the overall margin of error formula is the z asterisk with standard deviation divided by the square root of n.
Oh, okay, that's right. So if we are 6, dang it, what was theta? Oh, that's right, I have it on there. Okay, did you get 6.269?
Did you say 269? You cut out.
Yeah.
6.269. Okay, that's what I got. TJ got 6.652, and that came out right. So I don't know if that's just like the teacher giving like a range for rounding errors.
Uh-huh.
Or because I mean, obviously not every calculator gets the same thing, but I'm like, I got the 2 different ways that I knew how to do this equation, and I was just like,
What did you get?
6.269.
Okay, so
TJ put 6.652.
Okay, well, I can always submit it and we can see how it goes.
Yeah. It's like realistically, it's probably just the teacher giving room for rounding errors.
Yeah.
He might have just used like the first 3 digits of the standard deviation instead of all of them. I don't know. And then in lower bound, I got 5.303.
Correct. And then for the upper bound, I got 18.670.
I got 607, but
because I got 18.609. And so the 9 would round to a
yeah, let
10.
me just see. I might have, yeah, I just typed it in wrong. I think 18.6. You got 607.
I got 70.
70. Okay, so in my upper bound on my descriptives, I got 18. I got 18.6065, so I just rounded it to 18.607.
Where did I get that other number? I wrote it down wrong. I don't know where I got that number. I got 18.60 and then I put 9.5. I probably got dyslexic. Okay, so
It's like I was gonna say up here it just says 6065.
yeah, you were right. I just wrote down the number wrong. I don't know where I got that from.
It's early.
Okay. Yes, it is. Okay, so I will submit it.
Awesome sauce.
That goes. Okay, so we still missed number 4.
I don't know what else it could be. The value of the test statistic, because we tried just typing in even like the 4.
We missed the margin of error one.
The one where we got the different answer from TJ?
Yeah, we missed that one.
I don't know what we did wrong.
I don't either. Maybe we didn't round right?
Or maybe, I honestly don't know.
No, I'm going back and getting everything. Okay, content. Quiz. Okay, so let's look at number 4 right now.
Yeah. Okay, so the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test.
Is the hypothesis test two-tailed?
So we divided it by 2. So maybe,
because it says the determined for the hypothesis test, but it says that the one that they gave us in the problem is the greater than side. So what if we multiply that by 2 to get both sides?
but we're still only, oh wait. That would actually make sense.
You see what I'm saying? Because
yeah, because they gave us a test. Okay. So we were just thinking of it wrong.
I think that is kind of making sense.
That makes sense because it's the same logic. We're just looking at it in a way that's actually the right, because they're giving us for what's greater than. They gave us a different alternative hypothesis.
Yeah. So I got
versus me going
0.81. Okay, so I got 0.081. Is that what you got?
0.081, yeah.
Then the other one we missed was 17.
17? Correct. So, like I said, TJ's answer was, yeah, I gotta get to it, sorry. 6.652. And I'm just curious what he did differently than us. Because they give us the... $18.6 07 plus 5.303 divided by 2.
Hey, couldn't we to figure out the margin of error? Hold on a second. Okay, yeah, that didn't work. Never mind. Okay.
You come up with anything? Because I know I haven't.
I'm working on it right now. Data. Difference. That was nope. So it's not. I have no idea what he did.
I don't know. Maybe we can text him and ask him once we turn it in.
Yeah. We're close. We're really close.
Yeah, so it's just something simple.
I can only think of one more thing. What's the answer he got?
6.652.
Yep, that's not it either. Okay. I have absolutely no idea what he did. I've tried plugging in different numbers. So, because I thought maybe we were using the wrong number.
Yeah.
I even tried the upper bound versus the lower bound.
I even tried using the degrees of freedom instead of the n and seeing if that made a difference. And I'm just, there's,
It didn't.
it's like, it got us closer. But still not right. So we'll just text TJ and ask him that, like, when he gets a minute to explain it to us.
Yeah.
Or maybe if he's there on. But
yeah.
Let's figure out if we got it. We're right.
Okay. I'm still putting stuff in. 5 point.
Okay, I'll submit it then real quick and see if we got it right. Ah, we got it!
Yes! Logical thinking for the win.
Okay, so and then I'm just gonna send a text to TJ real quick and say, like, hey, buddy, oh pal.
It's at the very end of the explanation is at the very end of the meeting. And then can you explain? Blah, blah. Okay. That done. Okay, so same time Wednesday?
Yeah.
Okay. I will set it up.
Awesome sauce.
Thank you so much.
It's my pleasure. I'm glad we were able to figure things out, and hopefully TJ is able to help us understand.
Because that shouldn't be a hard problem.
Should it or shouldn't be?
Shouldn't.
I was gonna say, like, and we're getting something close, so my mind is just like, we probably entered something in to get like a wrong number in SPSS.
Maybe. I don't know.
No. I'm just saying, hey, TJ, whenever you get a minute, can you help us understand how you got 17? We couldn't figure it out. No hurry.
Yeah. So
I was like, because we have his emailed answers, so it's like I'm not worried about having to go back and look at what it is. So
yeah.
all right. Well, then awesome. We got 100% with only minimal amount of grief. So
Exactly. Okay. I'll see you Wednesday.
see you Wednesday.